All right, in this lesson, we're gonna solve rational equations. Now, we did this kind of in the previous lesson, right? So I'm gonna use the same videos for honors and regular, right? If you're in honors, we did something like this in the previous lesson, where we eliminated the fraction by multiplying by the least common denominator. The only difference with the problems in this lesson are that you might have variables in the denominator, and if you do, you need to check for an extraneous root or an extraneous solution, all right? Now, if we remember, right, so some time ago we briefly discussed what makes a rational expression undefined, right? Now, if I have something like 1 over x, right? So something like 1 over x, right? I know that x cannot equal 0, right? If I have 1 over 0, or any number over 0, this is undefined. All right, so once we get our solution, right, so maybe you do everything correct mathematically, but once you get your solution, if you plug it back in, you get 0 in the denominator, it is not a valid solution, right? So we'll get to some equations like that in this lesson. All right, so we'll start fairly simple. All right, so looking at the first one. So again, this is something like what we've seen in the previous lesson, right? If you're in my regular class, I'll show you how to do it. If you see fractions in the denominator, the goal is to get rid of them, right? We don't want to deal with fractions. I don't want to try to solve this equation the way it's written, right? That's going to make it a little complicated. So what we want to do is I'm going to multiply this entire equation by the least common denominator. Now between 3 and 4, right, the least common denominator is going to be 12, right? Think back to what we did in section P.5c, right, with our adding and subtracting, right? We had to find a common denominator, right? And between 3 and 4, it's going to be 12. So I can take that 12 and distribute it to every part of this equation. And doing that, I'm going to get a 12 times x over 3 plus a 12 times 3x is going to get me a 36x over 4 equals 12 times 2 is 24. All right, so it looks like we still have fractions, but let's try to simplify these, right? The whole point of doing this is to get rid of the fraction. And if we did it right, this should simplify, right? 12x divided by 3 is going to get us a 4x. 36x divided by 4 is going to get you a 9x equals 24. And then this is just a super simple linear equation, right? So 4x plus 9x is going to get you a 13x equals 24. And then you can divide both sides by 13, and so I get x equals 24 over 13. All right? So just because you get a fraction doesn't mean you did anything wrong, right? It just means you have a fraction, right? It's okay to have fractions as an answer, all right? But that's essentially the process that we do for these kinds of problems, all right? And I'll try the same thing for the next one, right? Number 2, let's look at the fractions that we have here. I have a 5 and I have a 3 in the denominator, right? So I'm going to do the same thing. Think about what the least common denominator would be, all right? They don't share any common factors, so it's going to be whatever 5 times 3 is, so 15, right? 15 is our least common denominator. And then when I distribute 15 to everything here, again, I can do 15 times 2x over 5. I'm not going to multiply it out just because I want you guys to get used to, as we go through these, you maybe find it a little bit tedious to write out the whole thing, right? So I'm going to write out part of it, right? So 15 times 2x over 5 plus 75x, right? So 15 times 5x equals 15 times 4 over 3, all right? And then what happens here is our 15 and our 5 are going to become a 3. Our 15 and our 3 are going to become a 5, and then I'm left with a 3 times 2x, which is a 6x, plus 75x equals 5 times 4, which is 20. All right, and then you just combine like terms. I get an 81x equals 20. divide by 81. And so I get x equals 20 over 81. All right. Again, it's okay that we have the fraction. Maybe you could skip this step. All right, so some people maybe just be able to do 15 divided by 5 and get a 3x, or a 3 times 2x, and a 15 divided by 3 and get a 5, right? So maybe you can jump from here to here, right? That's kind of the goal, because as they get more complicated, you don't want to write out every single factor. All right, but let's try the same thing with the next one. All right, so here we have a 5, a 2, and a 10. Again, our least common denominator in this case is going to be 10. Right, so I don't want to do all of them all together, right? Just because 10 has a factor of 5 and a 2. So I can distribute 10 to everything here. And let's see what that gets us. So I'm going to take my 10, my least common denominator. If I do 10 divided by 5, that's going to get me a 2. So I'm going to throw a 2 in front of this x right here. And I could do the same thing here. 10 divided by 2 is going to get me a 5. And there's an x here, so it's going to get me a minus 5x. Equals 10 times 3 is going to get me a 30. Plus, and then 10 divided by 10 are going to cancel out, so I get plus 3x. And then we combine like terms. This is going to get us a negative 3x. Equals 30 plus 3x. And then solve for x, subtract 3x on both sides. I get a negative 6x equals 30. Divide by negative 6. And then I get an x equals negative 5. All right. So that's essentially the process. If going from here to here was confusing, right, do it the way that you did number 1 and number 2, right? Shouldn't be anything super different, right? I just kind of skipped a step just to show you that you don't have to write it out every single time. All right, so I'll do the same thing over here. The only difference with this one is that now I have a variable in the denominator. So x and x, right? In this case, our least common denominator is going to be x. If I distribute an x to everything, right, this x and this x are going to cancel out. So then that's just going to leave me with a 15 minus this 4 and this x are going to combine, 4x. This x and this x on the bottom are going to cancel out. So this is going to equal 6. And then this x and this 3 are going to multiply. This is going to get me a 3x. All right. So again, if you need to write it out and say 15x, 4x, 6x, 3x, and then cancel these out, all right, that's fine. I just wanted to skip a step. All right. So I'm going to now get everything to one side. Doesn't really matter which order you do it in. I know majority of people like the positive x value. So I'm going to move the 4 to the other side, the 6 to the other side, and then we should get 9 equals 7x. Divide by 7 everywhere, and so I get x equals 9 over 7. All right. And so this is our final answer. Now with a variable in the denominator, all right, let me erase these. All right, with a variable in the denominator, you want to check. So checking if it gets you 0 in the denominator. Now in this case, if I plug in 9 over 7 in for x, I don't get 0 in the denominator, so this is a valid solution, right? So you might be thinking, well, the only thing that would make this 0 is if x was 0, right? That doesn't always mean that if you get 0 as an answer, that it is a no solution. I think the next one has a solution of 0 that is valid, all right? So we'll get to some later on that have no solution, and then hopefully then you'll see the difference. All right, so I'll try the same thing over here. Now, it looks like here, from the previous lesson, you could try and cross multiply. This is a fraction equal to another fraction, but just for the sake of consistency, I'm going to do it the same way that I've been doing the others. So I'm going to multiply by a least common denominator. In this case, a least common denominator, they don't share any common factors. So I'm going to multiply this entire equation by 2 and a 5x plus 6. And when I do that, when I multiply it to this equation, to this expression, hopefully we see this 5x plus 6 and this 5x plus 6 are going to cancel out. All right, so those cancel out, that cancels with this, and the only thing I'm left with is a 2 and a 10x plus 3. All right, and I could do the same thing over here. This 5x, I'm sorry, so this 2 and this 2 are going to cancel out. So if these cancel out, the only things that I'm left with are a 5x plus 6 and the 1 on top. So it's going to be a 1 times 5x plus 6. All right, and then I can just solve this as normal, distribute everything. This is going to get me a 20x plus 6 equals a 5x plus 6. All right, I can subtract 5x on both sides. And so I get a 15x equals, subtract 6 on both sides, equals 0. And then finish the problem, we're going to divide by 15, and so I get x equals 0. All right, so we do get x equals 0. That doesn't mean it's a no solution. I'm just going to plug it in and check. The only place where I see x in the bottom is right here in the 5x plus 6. Now when you do, right, so I'm going to check over here. When you do 5 times 0 plus 6, that gets us 0 plus 6, which is 6. All right, I don't care what number it is as long as it's not 0. So 6 is not equal to 0. So this is a valid solution. If it was 0, then it would be no solution. All right. So let's try the same thing over here for number 6. All right, so same thing. You could either get one of these fractions to the other side and then cross multiply like we did in the previous lesson, or again, you can multiply the entire thing by a least common denominator. Now between x and x minus 5, they don't share any factors in common. So I'm going to multiply by everything. And then I can distribute that x and x minus 5 everywhere. And it looks like, again, the x and the x are going to cancel. So we're left with an x minus 5 and a 1 over here. So I get a 1 times x minus 5 plus, and then it looks like over here, the x minus 5 and the x minus 5 cancel. So I'm only left with a 2 and an x. So plus 2x equals, and then 0 times anything is just 0. Right, 0 times x minus 5, right, the 0 just eliminates everything. So I can just solve this equation. So this is going to get me an x minus 5 plus 2x equals 0. Combine like terms, I get a 3x minus 5 equals 0. Add the 5 on both sides, and so I get a 3x equals 5. Divide by 3 on both sides, and so I get x equals 5 over 3. All right, now again, when you plug this into the denominator, there's 2 of them now that have an x, right? We don't get 0 in either of these, right? So this is a valid solution, right? And we're going to do a couple later on that don't have any solutions, just that you guys can see the difference. All right, but let's try the same thing over here. All right, this is a little bit of a bigger one. All right, so I'm going to take this entire equation, right, multiply it by a least common denominator, right? The 2x plus 1 and the 2x minus 1 don't have anything in common. So I'm going to multiply the entire thing by 2x plus 1 and 2x minus 1. So I'm going to distribute that to every single term in this equation. And then we can see that this 2x plus 1, this 2x plus 1 and this 2x plus 1 are going to cancel out. And so we're left with a 2x minus 1 and a 7. All right. And then we have now this 2x minus 1, this 2x minus 1 and this 2x minus 1 cancel out. So the only thing that we're left with is the 2x plus 1 and the minus 8x. So it's going to be a minus 8x times 2x plus 1, right? And then there's nothing on this side that it's going to cancel out with. So it's just going to be negative 4 times 2x plus 1, 2x minus 1. All right, and then we're just going to simplify this, right? Distribute that 7, distribute that negative 8, and then this is going to get us a 14x minus 7, all right, minus 16, looks like it's 16x squared, minus 8x, and then this is equals. And then I can multiply, I would FOIL those first because we see that that's going to get us a special product. So it's going to be a negative 4. When you FOIL this, right, it should get you 4x squared minus 1, right? It's a special product. And then you can distribute that negative 4, and then that's going to get us a negative 16x squared plus 4, And then on the other side, I can combine like terms, right? 14x minus 8x is a 6x. Nothing combines with negative 16x squared plus, and then nothing combines with negative 7. All right, so we get, this is our final answer. I kind of spaced it out weird. Sorry about that. But now we just want to solve for x. I haven't taught you guys yet how to deal with an x squared, but thankfully in this case, it cancels out. So that 16x squared and this 16x squared are going to cancel out everywhere. So I'm just left with a 6x minus 7 equals 4. Add 7 everywhere, so I get a 6x equals 13. Divide by 6 on both sides, and so I get x equals 13 over 6. All right. And then when you plug it into either of these denominators, we don't get any extraneous solutions. We don't get 0. So this is a valid solution, right? So all these up until now have been fine. All right, let's try this one though. This one's a little bit more fun. All right. So again, you always want to multiply by a least common denominator, right? But before we decide to multiply by all 3 of these, just because they don't look the same, we want to try to factor. Now this x squared minus 4 is a difference of squares. This is going to become an x plus 2 and an x minus 2. So I'm going to scribble that out. And then now I can multiply this entire equation by x plus 2, x minus 2. Right, because that's the only thing that matches, right? We don't have any other extra factors here. So I'm going to take this, distribute it to every single term here, and then hopefully we can see this x minus 2 and this x minus 2 are going to cancel out. All right, so cancel, cancel. All right, and then we're left with a 1 times x plus 2, and then x plus 2 and x plus 2 over here are going to cancel, but I'm still going to have this x minus 2 with that 3. So equals 3 times x minus 2 minus, and then it looks like everything cancels with this over here, so minus 6x. All right, and then this is just a super simple equation. I get an x plus 2 on this side. The other side I can distribute the 3. I get a 3x minus 6 minus 6x. And so I get an x plus 2 equals negative 3x minus 6, and then solve for x. So minus 2, add 3x. And so I get a 4x equals negative 8. Divide by 4, and so I get x equals negative 2. All right. Now when you check this one, right, so I'm going to check. The check over here, when I plug in a negative 2 over here in this denominator, that gets me a negative 2 minus 2, which is negative 4. That's okay. But when I plug it in over here, I get a negative 2 plus 2. That gets me 0, right? That is not okay. So as long as it shows up once, it doesn't matter which denominator it shows up in. As long as it shows up once, that is enough to say that this is a no solution. All right, so this is a no solution type of problem. Completely goes away, right? Just takes once for it to mess up that entire solution, right? So we would immediately say no solution. All right, so now let's finish up this page with these same kind of examples, right? This one I can do something similar. The only thing I have on the bottom is an x minus 4. So I can take that x minus 4 and distribute it everywhere. It's going to cancel out with the x minus 4 over here. The only thing I'm left with is a 3x. Now over here, it doesn't cancel anything with that 5. It's not even a fraction. So I get an x minus 4 plus, and then it cancels out with this x minus 4 as well, so plus 12. And then again, I would distribute that 5 to everything, and so I would get 3x equals 5x minus 20 plus 12. Combine like terms, I would get a 3x equals 5x minus 8. Subtract the 5x on both sides, and I would get a negative 2x equals negative 8. Divide by negative 2, and so I would get an x equals 4. But again, you want to check and make sure that it doesn't get you an extraneous solution. When you plug it in to these denominators, I get a 4 minus 4, which is 0, and another 4 minus 4, which is 0. I didn't even have to check both of them, right? Again, it just takes once for it to be a no solution. All right, so this is no solution. All right, so hopefully that clears up some potential confusion from some previous problems. All right, so I can try the same thing over here with this one. It looks like the denominator is already factored for me, so it should be fairly simple. Right, they share an x minus 1 and an x plus 3 in common. So that's our least common denominator, an x plus 3, x minus 1. When I distribute that everywhere, the x minus 1 and the x plus 3 cancels out over here, leaving us with just the 12. The x minus 1 cancels over here, leaving us with just the x plus 3 and the 3. So it equals 3 times x plus 3. And then the x plus 3 and the x plus 3 cancels, leaving us with the x minus 1 and the positive 2. So it's going to be a plus 2 x minus 1. And so again, just like all of these other ones, now that we don't have the fraction, should be easier to solve. I get a 12 equals 3x plus 9 plus 2x minus 2. Combine like terms and then solve. So I should get a 12 equals 5x plus 7. Subtract 7 on both sides, and I should get a 5 equals 5x. Divide by 5, and then I get x equals 1. Once again, when you plug this into any of the denominators, but again, doesn't need to be all of them, just as it only takes once. And we can see that when we plug it into this one, I get a 1 minus 1, which is 0. So this is a no solution. All right, so 3 no solutions back to back. You're not always going to get one, right? But that's why we check. It doesn't have to be a super rigorous check either. You don't have to fully show all of the work for it. Just as long as you can very simply show me 1 minus 1 is 0, right? That's all I need to see. All right, I can do 2 more similar to this. This is one where we can factor the denominator before we start multiplying, right? So something like x squared plus x minus 6. This is going to get us an x plus 3 and an x minus 2, right? I need factors of negative 6 that add to a positive 1. And then we see that when we do that, right, I can get rid of this now. When we do that, if I do x plus 3 and x minus 2, right, that is our least common denominator. I can distribute it everywhere. So this x minus 2 and this x minus 2 cancel. I'm stuttering a lot. This x plus 3 and this 1 are going to combine, so I get a 1 times x plus 3. And then plus this x minus 3 and, this x plus 3 and this x plus 3 cancel, leaving us with just the x minus 2 and the 3. So I get a plus 3 times x minus 2, and then everything cancels out over here, leaving us with just the 4 on the other side. And then I can distribute that 1, distribute that 3, and so I'm left with an x plus 3 plus 3x minus 6 equals 4. And then I get a 4x minus 3 equals 4. Add 3 to both sides, and I get a 4x equals 7. Divide by 4, and I get x equals 7 over 4. All right, and then when you plug this back into any of these denominators, it's not going to get me a 0, right? 7 over 4 minus 2 isn't 0. 7 over 4 plus 3 is not 0. So this is a valid solution. It does work. All right, let's try one more. All right, so this one I can factor out the x from the bottom. This leaves us with an x times x plus 3. And then I can multiply the entire thing by the least common denominator, which is x and x plus 3. So when I distribute that everywhere, right, it looks like just the x and the x are going to cancel, leaving us with a 6 and an x plus 3. All right, this x plus 3 and this x plus 3 are going to cancel as well, leaving us with a minus 2 times x equals, and it looks like everything over here cancels with this, right? So it's going to equal a 3 times x plus 5, and then I can distribute that 6, and that's going to get us to 6x plus 18. Minus 2x equals, I can distribute that 3, and that's going to get me a 3x plus 15. All right, so then I can combine like terms. I get a 4x plus 18 equals 3x plus 15. Get the x by itself, subtract 3x on both sides, subtract the 18 on both sides, and I get an x equals negative 3, right? But when you plug in negative 3, right, over here, right, we get a negative 3 plus 3, which is 0. And I don't want 0 in the bottom. This is another no solution. All right, so that's it for this lesson. Right, the hardest part is getting rid of the denominator, but once you do that, it should be a pretty simple linear equation, just like we did in the previous lesson, right? So that's always going to be the hardest part, and then maybe checking that it's an extraneous solution or not.